Hey there, this is Gaurav. Welcome back with another video of the series Learn JavaScript from Scratch. So we have already started learning operators, right? So this is a part 3 of operators where we will be learning the rest 2 operators, that is ternary operators and bitwise operator. And instance operator we will learn later when we will see the concept of object. So without wasting any further time, let's jump right in. Next we have ternary operators, or we can call it as conditional operators. So here is the syntax. First condition, then question mark, then if value is true, then colon, then if value is false. So in condition we will always have some condition like which will give you a boolean value in return, like whether true or false. So if it is true, then this part will be executed, like whatever you will write that statement over here, it will be executed. If it is false, then whatever you have written after colon will be executed. So let me show you one example, then we'll see something in action. So let's say there is marks 45. This is what you have got in the exam. So if I talk about the pass marks, it is 35. So if you get more than 35, then I can say you have passed the examination. So here is the result we are storing. So first we are writing the condition, that is marks greater than pass marks. So it is true because your 45 is greater than 35. So we'll get the first statement, that is pass. Let me show you some of the real life example using ternary operators. This is a very important operator we'll be using a lot in real life project. So before that, let me just clear it out and let me just comment this part. Okay, so we'll be talking about ternary operator. So first of all, let's say here is a situation where your height is, I'm just taking some random value, let's say 5.7. okay, now so next we have something called eligible height. So let's say eligible height it is, let's say 5.5. I'm just taking some random. So this is for if you want to join army, then this is the eligible height. If your height is more than 5.5, then you can join an army. So that's what we can do using ternary operator. So I'm just storing, let's say I'm just writing result, like whether you are eligible or not will be storing over here. Then let me just write the ternary operator that is something like this. Okay, so first I will write the condition, that should be your height should be greater than eligible height. So if it is true, then we'll write something over here. This line will be executed. Then we will store you are eligible. If it is false, it would be you are not eligible. Okay, that is a syntax. Let's see what you have got in result. It is saying you are eligible. That means first this condition will give you true, then the first one will be executed. Now if I change the eligible height, let's say 5.8, now it should give you you are not eligible. You are not eligible. So that's how you can use ternary operator, and it is very useful. Next one is bitwise operators. So the name bitwise means it will check bit by bit. We'll see that. So in bitwise operators, we have first of all bitwise and, that is single ampersand, but in case of logical operators we had double ampersand, right? Then we have bitwise or, that is single pipeline. Then bitwise XOR, that is a caret symbol. Then bitwise NOT, that is a tilde. Zero fill left shift, that is a double less than. Then signed right shift, that is double greater than. And finally we have zero fill right shift, that is triple greater than. So let us see all of these in action. First, bitwise AND. So in case of bitwise AND, it will check each bit and sets each bit as 1 if both are 1, else 0. So I mean the same concept which we have learned for a logical AND or digital AND gate. But here it will be applicable for bit by bit. So let's say we have one number x equal to 11, that is decimal. So here first we have to convert it into binary. That's where we will get bit, right? Now in binary we will get 1011. Let's take one more number. Let's say that is y, that is 13. If I convert it into binary, we'll be getting 1101. So these all are bit, like 1, 0, 1, 1. These all are bit. So now in order to get x bitwise and y, first we have to check each bit by bit. So in this table you can see we have 1011 for x, 1101 for y. So first we have 1 1 for both x and y, right? That is why we will get 1. Now in the second row we can see we have 0 for x, for y 1. So both are not 1, right? So we will get 0. In third also same, both are not 1. In y it is 0. That's why we will get 0. But in case of fourth row we will get 1 for both x and y. So we will get 1. So now if I convert this 1001, we will get 9. That is the result of x bitwise and y. So here I am showing one example. So now if I talk about bitwise OR, I mean the same concept, but here it will be applicable for bit. So here it is saying if any of this bit is 1, then we will get 1, otherwise 0. So again, let's say I am taking two decimal number x and y, 11 and 13, and the binary conversion of it would be 1011 and 1101. So now if you look at this table, so in the first row we are getting both 1, right? So definitely my output would be 1. In the second row we are getting single 1, that is for y. So definitely we will get 1. So in OR gate, if any of the bit is 1, we will get 1. In the third row also would be the same. For x we are getting 1, so definitely it would be 1. And for last row again both are 1, definitely it would be 1. So all are 1. So now if we convert this 1111 in decimal, we will get 15. So that is the output of bitwise OR. Like 11 bitwise OR 13 would be 15. So next we have bitwise XOR, that is caret symbol. So it says if both operands are different, then we will get 1, otherwise 0. So here operands nothing but the value, or I would say bit, where this operator will work. So let's say again I'm taking two number x equal to 11 and y equal to 13. I'll be converting it into binary. So now let us look at this table. So we have all the bit for x and all the bits for y, right? So in first row both bits are same, right? So we'll get 0. So it is saying in XOR gate both bits should be different, then only we'll get 1. So in the second row you can see both bits are different. One is 0, another one is 1. That is why we will get 1. In the third row also would be the same. Both the bits are different. That's why we will get 1. In the fourth row, both the bits are same. That is why we will get 0. So now if I convert 0110, we will get 6 in decimal number. So that is the output of 11 bitwise XOR 13. So next one is bitwise NOT, tilde symbol. So it says it will flip the bit from 0 to 1 or vice versa, like 1 to 0. So again, let me take one decimal number, let's say x equal to 11, because this operator will be applicable for only single operands. So that is why I'm taking only single number or value. So now if I convert it into binary, we'll be getting something like 1011. So if you now look at this table, then for x we are having 1011. So if I flip the bit, then it would be like 0100, right? We're changing the bit 1 to 0 or 0 to 1. So now if I try to convert it into decimal, we will get something like 4, right? But in real, if you try to do the same thing in console, you will get a different result, not 4. You will get something like minus 12. Try doing it now. Now you might be thinking how we are getting minus 12, right? So in order to understand that, we have to understand how JavaScript stores number behind the scene. So that is something we have already discussed, right? JavaScript is storing number as 64 bits, that is nothing but double precision floating number, right? But all bitwise operations are performed on 32 bits binary number only. So according to that, if I try to convert 11 into binary form, it will not be only 1011. The actual form would be something like this. We will be having total 32 bits, right? So only 4 bits we are showing. The rest other bits would be 0. So now if I try to flip it, if I try to use bitwise NOT, then all the bits will be changed, right? like all the first leading 0 bits will be converted into 1, and then we will get something like -12. So here -12 is nothing but 2's complement of this number, this big number. So here the leftmost bit would be used for sign purpose. So if you want to know what is 2's complement of it, you can write down in comment section. I'll create a separate video on that. So I'm not discussing on 2's complement in this video. So let's move forward. I hope you understood why you are getting -12, not 4. So the next operator we have, that is bitwise 0 fill left shift. So you can see we are having double less than sign, right? So if you look at this sign properly, you will see like it is trying to shift something towards left, right? So that is what we will understand now. In this operator, each bits are shifted towards left and 0 bits are added from right. Leftmost bit is discarded. So now again, let's take one number, that is x equal to 11. Now in binary form, we'll be getting something like this, total 32 bits, right? Now let's take one more variable, that is y, that is equal to, let's say, 1. This one number will represent how many bits you would like to shift towards left. So now if I try to do x double less than y, then this is what will happen. So this will be shifted by 1 bits towards left, 0 bits will be added from right, and the extra bit which we'll get in the left side, I'm showing in red color, this bit would be discarded. And finally we'll be getting something like this. At the end we'll be having 10110. This 0 is added because of left shift. So if I try to convert it into decimal, we'll be getting something like 22. That is the output. Similarly, we are having something like bitwise signed right shift, that is double greater than. It is just opposite to what we have seen just now. So here each bits are shifted towards right. If you look at this symbol, you will understand what it is trying to do. And 0 bits are added from left and extra bit is discarded. So we are saying signed because the bits which are added from the left, it depends upon the sign of the number. So it would be 0 for positive, otherwise 1 for negative. So again we are taking x equal to 11. This is a binary transformation of 11. Also we are taking y equal to 1 here. 1 is number of bits to shift. Now if I do x double greater than y, this is what will happen. So here now what will happen, this is a positive number, so 0 would be added from the left, it will be shifted towards right, and because of that the extra number, the overflow number, that is 1 from the right, would be discarded. So this is what we will get finally. At the end we will be getting 101. So output would be 5. The last one is bitwise 0 fill right shift. So here we have triple greater than. So we are not saying sign. That is the main difference between the previous one. So here each bits are shifted towards right, 0 bits are added from left, and rightmost bit is discarded. The same thing almost, right? But here we are not talking about sign. So again the same thing, if I take one variable x equal to 11, this is a binary transformation of it, and we are taking y equal to 1, that is the number of bits we want to be shifted. Now if I do x triple greater than y, this is what will happen. This will be shifted towards right, 0 will be added from left, and the rightmost bit, that is 1, which is the extra one, will be discarded. So again we will be getting something like 5. So that's all for this video. If you're having any doubt, any queries in this video, please let me know by giving a comment in the comment section. Thank you for watching. See you on the next video. For now, take care. Tata. Bye bye.